you've been working a lot with lines in Chapter 2, and you're still going to be working with lines in Chapter 2-7, but the lines that you're going to be working with you will get from scatter plots. So I want you to be able to fit scatter plot data using linear models with and without using technology, and to use linear models to make predictions. So let's first talk about regression. That's the statistical study of the relationship between two variables. And a scatter plot is a graph with points plotted to show a possible relationship between two sets of data. Now, what you're going to be drawing after you plot points is what's called the line of best fit. And that's a line that comes close to all the points in the data set. So how do you draw a line of best fit? Well, I'm going to give you a question here, but we're going to go down and I'm going to tell you how to draw a line of best fit first before I show you my graph. So what you want to do is you want to plot the points from your data set. So what I'd like you to do is turn the video off and go ahead and plot your points, and then turn it back on again. The second thing you're going to do is draw a line that splits the data evenly. So take a ruler and try to get as many points above the ruler as below the ruler. And you may or may not have the given data points on your line. The line is called the line of best fit. So don't try to draw a line through all of the points. You just want to take a ruler and try to split the points evenly. So go ahead and do that. The next thing you want to do is pick 2 points on the line of best fit. Now, when I say that, the points do not need to be in your data set. If you can, choose integer coordinates. It's going to make your slope a lot easier. Okay, so using the 2 chosen points, you want to find the slope and then write the equation for the line. So let me show you what I did, and I'm just going to have my points already plotted so it doesn't take as long. I plotted the points in pencil, and then I took my ruler and tried to split the points evenly, and let's see, I don't think I can line that up so you can see it. There's going to be a shadow on it either way. So try to split the points evenly above and below, and then you're going to draw a line of best fit. The reason why you're drawing a line is you're kind of drawing a line that is the average, I guess you could think of it like that, of the points. Now, these pink points here were not in my data set. That doesn't matter. And it doesn't matter that this line only went through one of the points on my data set. Again, you want to split the data set, and then you're going to pick 2 points. The reason why I picked these 2 is because they're integer coefficients. They're not in between the numbers like fractions or decimals. And neither one of those are in the data set. Doesn't matter. We just want to pick 2 points so we can find our slope. Okay, so I used those 2 points. I used 215, and this one was 835. And then you just do what you've been doing for the last few days. You find your slope. So I use those 2 points. 35 minus 15 over 8 minus 2. And I think I need to slide that up a little bit so you can see it. And so my slope was 10 over 3. Then I chose just one of those points. I chose 215 to write for my x and y. My slope is 10 over 3. And then I just substitute that into y equals mx plus b. And then my intercept ended up being 25 over 3. So when I write the equation for my line, y equals 10/3 x plus 25 over 3. Now, we could do all this with a calculator, but there's really no sense having you do a calculator if you don't understand what's going on. So you want to, again, split the data as much as you can, draw a line of best fit, and then pick 2 points that are integer coefficients. And those were the only 2 I could see that were integers. All the rest of them would be decimals. So then I wrote the equation for the line. All right, on the next page, we need to talk about correlation coefficients. And correlation is the measure of the strength and direction of the relationship between 2 variables or data sets. So there's a number that's referred to as a correlation coefficient, and that number has to be in between -1 and 1, and including -1 and 1. It describes how well the data is represented by the line of best fit. So here's what you need to look at. If the numbers are clustered closely together, that's going to be show a strong correlation. This one would be weak because they're spread apart. This one, there would be no correlation. This one would be weak because what you're looking for is you're trying to see if it's going down or up. And this would be called a strong negative. This would be a weak negative. This would be no correlation at all. This would be a weak positive, and this would be a strong positive. And I'll tell you why that's important to know what kind of a correlation coefficient you have. You can refer to the correlation coefficients as having strong or weak. So we have strong and weak up here, positive or negative correlation. So we're going to use these graphs. We're going to put them in the table. A strong negative would be like a negative 0.95. A weak negative would be a negative 0.6. This would be no correlation, and I don't have a spot for that because we're just talking about strong and weak, positive and negative. This would be a weak positive because the points are kind of spread out, but we can still tell that it's trending towards positive. This one is the points are very close together, so that's why it's called a strong positive. If there is a strong linear relationship between two variables, the line of best fit can be used to make predictions. So if I graphed my data and it looked like this, and I tried to do a line of best fit, I really wouldn't know if it would be positive or negative. I don't want to make any decisions or predictions based on that line. However, if the points were clustered closely together, then I would feel comfortable making a prediction about the future based on that data. Okay, do not confuse, circle that, do not confuse slope with the R value. The R value and slope have the same sign, so a slope for this line would be negative, negative, positive, positive, but you could have a slope of 5 and a correlation coefficient of 0.6 because remember, the correlation coefficient can't be less than negative 1 and it can't be greater than 1, so it is not your slope. Okay. Why do you use a line of best fit? Well, many times in life, graph data does not form a straight line, but decisions need to be made based on data. So you can think of the line of best fit as a prediction equation. It may be used to make predictions based on given data set. So we're going to use the line of best fit on the first page, predict the number of hits that Vern's site will have. So the question, if we go back to here, Vern was recording all of the hits that he had on his site, and we want to see what happens after 27 days. This only went up to 14. So we can make a prediction for 27 because we have an equation. So we're going to use that equation that I found on the first page, and we're going to substitute in 27 for the days because that's what it represented, and we'll find out that he should be getting approximately 98 1/3 hits. So we'll just say that that's 98 hits. But when I go back and look at my graph, it really doesn't have a real strong positive. I would say this is more like a medium positive. So the best time to make predictions is when you have something that would look closer to these. So is it a strong correlation coefficient? No, it's more medium, but we don't have a choice for that. They're just classified as strong or weak. Okay, I'm going to have you draw a graph, and the steps are here that you need to do. And your table's here, or your graph's here, your table's here. So go ahead and do a line of best fit. You can look at the previous page for directions if you need some help.